So how will we put into symbols that we can then use later this idea of pick 2 points and draw the line segment between them and see if it goes outside the set? So let's use x0 and x1 as 2 points in some space that we're operating in. And alpha being a scalar that could be 0, could be 1, could be anything between 0 and 1. Then we're going to define the convex combination of the points as the set of all these points where alpha ranges from 0 to 1. So you could say it's a linear combination, something times this plus something times that, but with two special things about it. The sum of these weights is 1, alpha plus 1 minus alpha is 1, and no weights are outside the interval 0 to 1. Let's take a quick look at it. Here I've got a point defined here and a point defined here, and I've got an alpha slider, and I can slide alpha. So what do I get if alpha is 0? I get basically alpha 0 times a1 plus 1 times a0, or x1 and x0. So if alpha is 0, I get the point x0. And then alpha smoothly interpolates up to the point 1 when vector x1 when alpha is 1. And if I pushed alpha beyond 1, I would get something that's not on the line segment between those 2 points. And if alpha was negative, I would get something over here. So that's our idea of a convex combination. So here's a fun little puzzle. How would you define the convex combination of more than 2 points? Like if I just put 3 points down in the plane, I'm going to say the convex combination is the filled-in triangle with those points as vertices. How would you write that in symbols? Take a sec to think about it. Well, you could say instead of just alpha, I've got a weight for each point, which I actually had here. It's just that whatever the weight was for this point, I used 1 minus that, which is a weight for this point. But now I have kind of more freedom. The sum of the weights still has to be 1, and each weight has to be between 0 and 1. But I'm just doing a linear combination with these two special situations for it. Can you think, would this kind of combination ever give a shape like that hexagon with the missing slice? I'll let you think about that. So next we'll put these ideas together and talk about functions being convex, even though functions aren't regions.